Western Douglas doing a master's in it. So he's doing a master's at UNJ, so a bunch of cool jobs all over the world, essentially since then. So most of them based in the U.S. We're traveling internationally, I guess the last 15 years now.
Yeah. Two 48-page fast books full. So I've been a lot of places.
Yeah. Anyone thought that? Okay. So Doug's got a very cool career. He's now just joined Ekso Bionics. Before that, you were at GE.
Yep.
So GE before that, then a lot of other big companies like Siemens, Boston Scientific, if I recall correctly.
That's right.
All the place. So, but now Ekso is kind of an early stage company. It's technically a startup, but not an early stage startup, but one that's been around for a little while, doing some very cool things with Bionics. So, start with, I guess, any background information you want to get on my childhood, growing up, and that kind of
Yeah. So I'm originally from Ohio, Mississauga-on-the-Lake, which is known as Cleveland, which the Warriors have competed with in the NBA Finals. I always wanted to be a doctor. I did my undergraduate at Bowling Green State University, and actually it was biochemistry. And I then quickly decided I wanted to explore a little more creativity than what I viewed medicine to be. At the time, I interpreted as more observational-based learning. It means you do 50 procedures, and then more or less you are now an expert in doing those procedures, and now you can try it. And I just don't think that way. Yes, medicine's different than that, but that was my interpretation. So I decided to go to business school. I did 2 years, I got a master's degree, and as Robin said, I started off in corporate marketing. Now, I've worked on implantable defibrillators, which is a class 3 medical device, at Boston Scientific. I worked with drug-eluting stents, so that means if you have like an arterial blockage, they can open up the artery and put a stent or a metal mesh in that could prevent the artery from being blocked again. I've worked in the dialysis space, or peritoneal dialysis. It means it's another form of filtrating your blood because you may have a kidney issue or some type of residual renal problem. I work on handheld ultrasound. I helped work with GE Healthcare on the world's first handheld ultrasound. It's the size of a cell phone called Beastie. It's pretty cool. I then moved into premium radiology, and then on ultrasound systems, and then I'm doing something new now. I am now heading up marketing at Ekso Bionics, which they are the makers of powered exoskeletons for medical or industrial applications. I'm going to talk to you more about that today. But before I get into that, I actually want to show you a little video. So just give me a second. So many of you may not know that out in the world there's a need for exoskeletons beyond what you see from Marvel and the Hollywood movies. Why don't you take a look at this video?
At Ekso Bionics, we believe in giving people hope and helping them reimagine their functional limitations. This is why we don't just design early mobility aids, but rehabilitation tools. Tools that give physicians and physical therapists advanced therapeutic options. Ekso GT with Smart Assist software is a gait therapy device for patients with stroke and spinal cord injury. Made to get these patients back on their feet. By correcting posture and promoting natural ambulation, Ekso GT helps build confidence, strength, and endurance. As proven in a pan-European study, Ekso GT demonstrates a statistically significant increase in time up, time walking, and number of steps. These benefits are currently being studied more closely in an industry-first, randomized, multi-center clinical trial called WISE. We believe together we can change the standard of care. We believe in supporting patients' hopes of early mobility and independence. We believe in you getting back on your feet and feeling like yourself again. Our hope is that one day you won't need us. Join us on www.ekso.com EksoBionics.com on Facebook, LinkedIn, or Twitter. Take the next step with us.
Okay. So a lot of complex ideas there that I can elaborate on, so don't worry. So look, first of all, when you hear about exoskeletons, the first thing, the analogy everyone's going to say is Iron Man. Right? I'm just going to mention that. But what you have to understand is we are in business to make products and robotics that help people. Okay, that's first and foremost. It's not, sexy DARPA secret projects, although we do dabble in military. But really, we believe that helping people that need it most is where you want to start. So what you saw there is there's a medical arm and there's an industrial arm, and I'm going to talk about that. So first and foremost, we have a powered exoskeleton called Ekso GT. Okay? The idea behind this is if you have any type of mobility impairment, this could mean, for example, that you had a stroke and you had paralysis as a result of the stroke. That means that you have trouble with what's called gait. And gait is essentially your body's ability to naturally balance. You're doing it without you even realizing it, but you understand taking a right step versus left step. You have to balance in a certain way. Some people lose that ability, and that means they will be permanently debilitated and have to live with other types of forms of locomotion. So they might have a wheelchair you've seen. You may see canes, you may see other things. So Ekso GT simulates the most natural way the body walks. So they'll go into rehabilitation. They'll get in this device and start to take steps. Now, this is why it's important. In rehab, you would have some person that would help them take steps, and they may only be able to accomplish 200-300 steps in a session. Well, with technology, we can program the device to take 2,000 steps, and then the person will now start to relearn, and like you would in rehab, gain their ability to walk again. Okay? We have a lot of brilliant engineers where we work on the Richmond Marina front for the medical portion of the business. The other side of it is industrial. So this one's interesting. Both of these products that I will explain affect quality of life in different ways. Actually, I was just mentioning to Robin, I was in Sacramento this week at a photo shoot where we're filming construction workers using exoskeleton technology. So this means, for example, it was 110 degrees in the hangar that we were filming at. Imagine a person working 110 degrees all day with 35 or 40 pound power weight heavyweight tools. This is what happens. They get work-related injury. Okay? So our industrial business focuses on what if we could take what we've learned about robotics and take 100% of the weight out of a power tool. And that's a product called Ekso 0G. It actually does that. There's an arm that's actually mounted on, let's say, like an aerial work platform or a scaffold, and actually can take 100% of the weight in. We're showing competitions versus, you take a little guy like me versus a big linebacker dude that works like this all day. I'm literally drilling concrete with one hand and my cell phone in the other, just like this. Whereas he's picking up this 60-pound weight, and that could change the world. So this is what Ekso Bionics does in a nutshell. I'm going to talk about a lot of other things, but I think in the end, we are making it a business and we are designing technology for the people that need it most. And later on, we can get Iron Man suits for all of you if we're successful at that. Okay? Sorry, I sent the wrong presentation to Robin, but it's okay. That's okay.
You guys, feel free to ask questions. I'm just talking to.
Yeah, I'm very informed. You'll see I'm very informed. I'm a father, I'm a motorcyclist, and I'm the hardest core video game player you probably know in any corporate America. I'm really into Destiny and Dota and StarCraft. I'm sure a lot of time wasted you guys all do with those things, but I'm doing them as well. Let's first talk about a little bit you may not know about. So if you make a technology, you make, let's say, something that's really cool. If nobody knows about it, that's problem one. Two, if it doesn't meet a use case and solve a problem, no one will use it. So a lot of the challenges we have as a company is we developed this amazing technology that some people even say, I didn't even know this is real. This isn't experimental stuff. You can actually buy these things. But many people struggle to understand how to use it. And those people are actually our customers. And I actually think any of you that get into engineering, you're going to have to think more about what's called voice of customer. There's a lot of skills in that area, quality function deployment, different things. But for us, our customers, and it may be hard to see, but I can elaborate. Look, if a person wants to get an exoskeleton, you gotta have the patient who's your end user, right? They gotta get in, there's gotta be inputs for them to give feedback, they have to be able to mechanically get in it themselves, okay? There's a physical therapist, which is an individual that administers rehab. That means they're skilled, they're trained to keep the patient upright and safe, right? There's a physician who's the one that will prescribe, like this person needs X amount of steps. And then lastly, there's some administrator or some business person, right? Business person is at the end of the day will make an investment. All of them have to be in alignment for us to move forward to get an exoskeleton out to an individual, okay? So that's complicated. But what this means is you have to design, my message to you is design your technology or design your projects with a specific use case in mind, a specific people in mind that have certain needs. If you do that, then it's going to be very clear how they use it and what they do. So I think that's important. So some of you may wonder what goes into an exoskeleton. There's a lot of stuff. So first of all, it's wearable, so you get into it, right? It's definitely not a robot. You'll hear, we joke in the office, there's a big distinction between a robot and an exoskeleton. Like, a robot is more independent, right? Like this is like kind of like AI, like Watson or Siri, right? Like you tell them something and then you do something, right? But they're still based on some programming. An exoskeleton, you can think of it this way, augments an individual. So there's the same person. It's not that it's a different thing now. It's driven by a person. So the user would get in it, and then there's a handheld controller that's behind him. So the gentleman here, he's my coworker Daryl, he's actually a physical therapist. So that means they can control and manipulate how the device works. So for example, like if you're going to really get a workout in, you guys, if you go to the gym, you know, like look, hey, I want to work on both legs proportionally, right? But there may be an instance that maybe the patient has a weaker leg. Well, if they use the device, they can make it harder for them to work with that leg and they get a better workout. So the idea is the device adjusts or adapts the resistance necessary to make sure you get the right dosage, is what they would call it. But it's basically to get the most effective use of rehab. Then there's adjustable software. So this is interesting. You can actually have the device compensate for the way they walk. So the device is actually learning more about you as you kind of walk in it. It knows if you kind of like hesitate in a certain way, it can start to estimate with algorithms whether you're going to go through the full step. And there's different software that's out there.
So basically machine learning. Is that fair to say?
That's fair to say. Fair to say. Fair to say. Any questions so far? Yeah.
Wait, could you elaborate on like why an investor is needed to get an exoskeleton out? By an investor, do you mean someone who like just pays for it?
Yeah, so let me explain. Right now, in rehabilitation, there's no standard of care. So by that, it means exoskeletons are totally new. There's no reimbursement, right? There's no method that you can, for example, if a patient came into a center, the center would have to actually purchase the equipment to actually administer this. Are there other options? Sure, we try to, again, it's all about trying to get the device to the people that need it, right? So we have rental models, we'll allow hospital centers to lease it, but look, I think all of you know, like when you design a product, there's gonna be a certain amount of components that have a certain cost, right? We have to make essentially a device that meets the need and at a price point that the market can pay. So that's really, and that's a critical requirement. You're going to hear about this. It's a target cost, or you have to design towards a target cost. You always have to keep that in mind. Like, look, if you have a project, it can't be like $1 million to produce the result of the project, right? Like, you're a student now. Like, you don't have $1 million. So that's the kind of situation that we're facing, except just out in the marketplace. So we're trying to make this affordable. We are finding ways. There's foundations we work with, that people that donate money. We partner with organizations like, for example, Soldier Strong, which they go to veterans and they actually try to get people in the community to donate so that veterans that can't walk can actually use the exoskeleton in rehab. So yeah, it's a challenge. I would say anytime you try something new, that's going to go through a situation where, yeah, someone's going to have to make an investment. And the idea is, if they have to make an investment, we have to make sure the device does what's intended, but then we can also prove it, which is a good segue to where I'm going to talk about studies.
I have a question on that. So you mentioned there's no standard for what's covered. So, for example, like a prosthetic, like a I lost part of my leg, that will be covered by potentially, I'm not sure.
Maybe.
Maybe.
But that's what I'm saying. That's that. There's no standard of care.
Yes.
It doesn't mean that you won't get, for example, access to rehab. You will, but does it meet your unique needs? And is it always going to have the technology that maybe you want that maybe they don't even have? That's why I'm saying there's no real standard there. Like some people have robotics, some centers don't. Some believe in we'll just have more physical therapists, and it just may take 4 or 5 people to get you to walk. But right now, yeah, we are working, we're collaborating with others in the industry to develop guidelines, one, and then two, to make the argument for some form of reimbursement.
Do you have any examples of an active prosthetic that is covered by existing insurance? Any stories of it?
I mean, the most obvious one would be, again, going back to the wheelchair. I mean, it's not a prosthetic, but look, if you need mobility and you have impairment, you know, you're going to need a way to get around. And the wheelchair still, I'll put it this way, the almighty wheel is still one of the most amazing inventions ever. I mean, we make jokes about this, so let me say, we work at, actually you guys don't know, at Ford Point. So Ford Point is where the original Model T was mass produced. So by Model T, it's like the first car, right? Which, it's interesting, that was the first invention to offset the horse and buggy, yet now we're in there designing a device to offset the wheel, right? So, you know, it's an interesting story overall, but this is a good point. Yeah, there is no true standard of care when it comes to robotics in rehab. Maybe I should qualify that a little bit better. But how are we going to get there, right? So, studies. So right now, we've studied over 560 patients, and we believe we could prove standard of care around 1,200 patients. We have different studies across stroke, spinal cord injury. People actually, I mean, we get all types of requests. People want to come forward with other types of neurological disease, MS, and there's other things. Right now, our indications for use, they're online. Full indications of use from the FDA are spinal cord injury and stroke only. Okay. Oh, wrong one. Okay. Clinical trial. You saw that in the video. So what is a clinical trial? The idea here is when you're making a medical device, you have to prove 2 important things. That the device is safe and that the device is effective. That means safe means, look, nobody's going to go into it, in our case, have an adverse rate of falls or injuries or things that were unintended, right? Effective means it does what I say. Okay? So we are going into a multi-center randomized clinical trial. What that means is, look, you want the study to be done in a way that the facts speak for themselves and that you're taking out bias, right? So we're going to 10 centers. There's on our website, there's about 5 of them enrolled. So there's Burke, that's in the East Coast, RIC's in Chicago, Gaylord, Marion Joy, and Kennedy Kruger. So all of them are enrolling people with spinal cord injury. And our clinical trial name is called WISE, which is a wearable improvement in spinal cord injury with exoskeletons. So what we're trying to prove is that using the exoskeleton could prove a benefit above and beyond if they used manual therapy, okay? Or some other form, like a body weight supported treadmill or other things, okay? So you can actually, I know you're part of the millennial YouTube generation, although I love YouTube. So there are videos online where you can actually learn more about this whole thing, and this is an area where, if you're going to develop technology in medicine, there's no way around it. If you really want to prove that your device does what it does, you got to put it to the test. Okay. This is another. Let's see if it'll play. Maybe it won't. Will it play? There we go. Okay. So this is actually brought to us by our friends at Kessler Institute. Her name's Karen Nolan. She actually did a TED Talk about trying to design robotics for stroke. And actually what you can see is she put motion capture balls on someone walking with an exoskeleton. And what you can see here is the device, when even working with a cane, it's trying to simulate how a person walks. Now this person looks like they definitely have some form of mobility impairment in one leg, but this is where the device can make certain adjustments by just changing the settings. Okay, so I mentioned before there's a lot of sites or a lot of centers. There's over 170 sites that are doing this already, actually. So, and this is not for like research purposes, that they actually purchase the device and patients go to them specifically for exoskeleton rehabilitation. I'm trying to watch the time, so that's why I'm moving a little fast. Okay, I talked a little bit about construction. Oh, I went too far. Okay, construction. So same issue. We're trying to accomplish quality of life improvement, but at the same time, what I want to show you is that users change. So we have construction workers, right? So somebody could work in demolitions. They could ship concrete. They could build things. It could be on an automotive manufacturer assembly line. These are all different people with different needs, right? So our engineers got together and said, look, we could design this 0G, which is an exoskeleton arm, okay? And the arm essentially takes 100% of the weight out of a heavyweight power tool. But there's other constituents. So for example, the site supervisor is actually similar to like the administrator, the person that had to invest. The site supervisor has to say, hey, look, for us to stay in business, I got certain economics I got to think about, right? Like I got to buy trucks, I got to buy materials, and now, but if I make an investment in safety, maybe I can reduce work-related injury. Right? Maybe I could I could help people feel better. Right? That can make a big difference. If somebody's morale is higher, they say, hey, I'm not going home, I can pick my daughter up. I can hug my wife versus my arms are just exhausted and I just have to take all this pain medicine. Then we have a safety officer that might be concerned with these things. So all of these, which you can see here, is we're applying exoskeleton technology in different ways. And we have engineers that all think differently. This is a total different situation, total different use case.
And then say all these different engineers plural, probably have to work a whole bunch of different types. What are examples of different types of engineers that are working on
Very
different
good.
pieces of this puzzle?
Very good, good question. So you have certain engineering that's focused on planning, scheduling, okay? So that's like project management, that's a career. Another one could be a design engineer. So the idea here is there's some requirement, or this is what we're going after, and that would come from the commercial business, right? Like, hey, we want to solve this problem for someone. They're the ones that actually start to break it down and think about what are my design options to actually solve the problem, okay? You have requirement engineers. So that means, like, for example, more documentation, more of like the product shall do X for some user, right? So that would be like, for example, like the product shall be ergonomically comfortable to put on, right? Which means, you know, you might want some soft leather or some soft material to interface with the human skin. Other engineers, you have patent, so people that are patent submitters. So true, like basic research, IP, they're dreamers.
Well, I have to have legal for that, right?
You have to have legal. So we have legal on board too. So there's a variety of different roles that engineers play, and then you get some engineers that actually have to work with marketing. Dare I say this? Usually, you know, marketing, we usually get a bad rap, like we are like the dark side of the force, or the evil empire. You know, you'll see this in Hollywood. But truth be told, look, when you're designing products, you need different individuals to play different roles. In a lot of ways, I run into direct point in contact with customers, and I will have certain intel that engineers want. Or they have a certain picture of how a feature works, and then I have to translate that into so the marketplace understands it, if that makes sense. Okay? Going back to industrial, right? So I don't know if you guys know, there's over 625,000 occupational injuries that occurred in manufacturing in 2015, and it cost over $21 billion in terms of worker compensation. That's a big problem, big macro problem. And that's what our company does. Like, we're really trying to solve this issue. There's one more slide I want to do, and then I just want to go into total questions. This is one. There we go. Perfect. My book recommendation for all of you is a book called Crossing the Chasm. Have you ever heard of it? Raise your hand if you heard of it. No? Okay, good, right? So you're going to go on Kindle, and you're going to find this book, and you can thank me later on for recommending it to you. The designer's dilemma, the engineering dilemma, is how is your product going to be accepted by people? And is it going to be accepted by a niche, small crowd, or everybody? And that book essentially indicates if your x-axis here is time and your y-axis is acceptance or consumer acceptance, you can start to see a curve or distribution of how a product is adopted. So early on in the phase, you'll get two people. You get the innovators and the early adopters. That means like me in video gaming. Like I have a water-cooled Alienware that is completely overclocked and has an amazing video card, like Titan GTX. But see, not everybody's gonna do that, right? Only the true enthusiasts, right? So you're gonna start with that crowd, but then to get to mainstream adoption, meaning everybody loves your product. Like if you're in a competition, you really wanna win. You want the most amount of people possible to accept your design concepts or your philosophies. To do that, there is a break called the chasm. And that is a technology gap or void. It means that you will have certain critical issues or challenges you will have to face. Notice we were talking about reimbursements, right? Guidelines, standards, education, maintenance. For an industrial, it's cost reduction, switching costs, business model. Once you solve that, this is when you move into this, with this right skewed curve where you get into the big groups. Like, if they use it, then I'll use it. That's the way they think. Or, your prices are too high because now you're so big, it's like it's a commodity, right? Like those Apple iPhones, I think you all agree, they cost too much, right? But that's good problems to have because it means the product is so far out there, the consumer already has like a reference in their mind. Like, well, everybody has it. Why should it be so much? But this is really something I really think, it's for exoskeletons, but it's a book that I think all of you should really take to heart. Whenever you start a project, always think about, what's my target? Like, for some you may say, hey, I'm not trying to make it mass market. I just want it for me and my friends, right? Like, I want an item manager for my Destiny like clanmates. So I'm only gonna make it for them. But if you wanna make for everyone, yeah, well then you gotta consider what are the barriers, right? What are the issues, what are the challenges, okay? So, crossing the chasm. It's okay, you can write in your phone. I don't think that's abusive or anything, okay? So, questions. I'm sure you have questions. My friend.
The construction exoskeleton arm, is that like electrically powered?
No, very good. So, okay, so we have the medical exoskeleton is electrically powered. It has a form of like a lithium-ion battery that's on the backpack. Okay. Now the industrial one is completely mechanical. So it's mechanical motion, levers and pulleys. Like it's just basic physics. Okay. Are we moving towards a powered industrial one? I mean, we're trying to do a lot of things, but I'd say let's go back to the customer, to my point. Voice of the customer. Construction workers needed something that was cost effective, easy to use, it can take the heat, and it can take the beating, right? So it just didn't make sense to add a lot of complexity. So that's for the arm. But we do have something, if you go to exobionics.com, that's really cool. There's a vest. Now the vest, I don't know if you've ever seen the film Elysium with Matt Damon. Maybe you need to go on Netflix. That's the design philosophy of our vest. That look, we can augment what if we put something on, and if somebody had to do some overweight work with a tool that's like 30 pounds, what if you could put pulleys and levers in the same concept on their back, and they could take 100% of the weight away? If you do that, you can change the way auto manufacturing is done. You can change the way the drilling under a bridge is done, and then you're really changing the world. So that is something that, it's not available yet, but it is on our website in pre-sale. People can see what it's about. Question?
Has the arm been implemented at any construction sites yet, or is it just experimental?
It has. No. Everything I'm showing you is actually out there. Hold on, let me show you. Yeah, here we go. The Ekso 0G itself, the arm, is used in 20 sites already installed. Okay, we got Siemens, my former employer. Right? You have Apache, Landmark. PCI actually is a construction group that we are working with them, and one of the engineers actually works at the Tesla site. So you'll see, yeah, this is not like you saw all the way down in the innovator. We haven't crossed the chasm yet, but yeah, it's starting to get adopted pretty quickly. This has only been out maybe a year or less than a year, so it hasn't really been out very long. But a lot of it is people want to do pilots. So yeah, think of it this way, like your common workflow on a day on a construction site is completely changed by this, right? Like you gotta first set it up, you gotta train people, then they use it, right? But that takes time. So a lot of people are kind of like 1 foot into the bathtub, right? Like they're taking their time.